put some shapes on the graph, okay? So, and in order to do that, you need the vertex, right? So, let's start out by talking about all these words that were in bold here. Axis of symmetry, vertex. So that's what I want to talk about first. So, when we talk about an axis of symmetry, well, let's talk about the vertex first. So go ahead and just sketch a quick little coordinate plane here. Okay? So when you have a parabola, and we're going to talk about what the axis of symmetry is. Well, let's do the vertex first. So if I were to have a vertex or a parabola that's shaped like that, okay, obviously it's a little better than that. So we got to talk about what the vertex is. The vertex is this point right here. Or if you're, let's say you have a narrower one, it's this point right here, okay? So the vertex can either be, depending on whether it's opening up. We call this parabola a parabola that opens upward, or up. Obviously, it's opening up, common sense. So this one is a parabola that opens down, okay? And this means that you have a positive y equals x squared, right? Remember? We're going to talk a little bit more about that. And this is a negative, meaning y equals negative x squared. So when there is a negative in front, it's going to open down. Okay, that's the first thing. So in standard form, like as you're looking through these, you don't see a negative, that's an opening up. Do you see that negative? It'll open down. See that negative? It'll open down, but this one will open up. That's really important, okay? So that's the first part about it. The second part about it is your vertex we're going to refer to as either the highest or the lowest point of the parabola. Okay? When is your parabola going to have a highest point? When it opens up or down? Highest meaning the highest it's going to go up. It's going to have a highest point when it opens down. And we call this is called the vertex. Go ahead and point to that. Point to that, call it a vertex. But vertexes can also have more than one name to it. Meaning, if this is the highest point of it, we're going to call this vertex a maximum. Because that's the highest it goes, right? If the parabola opens upwards, the vertex is also referred to as not the highest, but the lowest. And what's the opposite of maximum? Minimum. You'll hear minima and maxima. They don't put the M on the end. So minima, maxima. I don't just always put that. Okay? So when it's the highest point, it means that it's opening down, which is a maximum. This is not something you memorize. This is something you visualize and you use common sense and think about it. If it's the lowest point, it means it's opening upwards. And if it's opening upwards, the lowest point is a minimum. Okay. That's the first thing, the vertex. So I want you really familiar with what the vertex is. It's going to be the most important part of the parabola that we talk about. A second important part, so this was vertex notes. Okay? The second thing that I need you to be familiar with on a parabola is something called the axis of symmetry. And what you need to know is that parabolas are symmetrical shapes. So go back to, third grade or second grade when you learned about symmetrical shapes, right, and lines of symmetry. They would give you a shape and then they ask you, what are the lines of symmetry in this? And what a line of symmetry is, and usually they are represented by dotted lines, right? Okay? What that means is if you were to fold this, I should have gotten some patty paper. If you were to fold this on that dotted line, would everything over here match up with everything over here? Yeah. Okay? So because it's a square, I could have this. And if it was a true square, I could even have an axis of symmetry from corner to corner, right? And then one from this corner to this corner. Then the shapes got a little crazy, right? They gave you, shapes like this. Now, is this an axis of symmetry? No, but is this? Right? That side folds over. Okay, so parabolas are symmetrical. Meaning, if, obviously this one isn't that I just drew, but if in a perfect world, if you drew it, you should be able to take that axis of symmetry, which we're going to talk about, fold it over, and then this arrow should land on this one, if it's done correctly. So I want you to draw a little coordinate plane real quick. And an axis of symmetry, then, is a vertical line. So, an axis of symmetry is a vertical line that we're going to say it cuts the parabola in half, I guess. And creates two equal, halves, obviously, and it goes straight through the what that we just learned. Think about it. If this is the axis of symmetry, it's got to every single time go through the vertex, doesn't it? And it goes through the vertex. Okay? So for example, if I were to tell you that the axis of symmetry, and by the way, how do we write vertical lines? What's the equation for a vertical line? Remember, the only ever time it's not y equals y equals y equals is when it's a vertical line. So it's an x equals. This is where I'm going to use my purple today. Every line of symmetry is going to be drawn in purple. So I'm going to have you just kind of draw a purple dotted line. And that's going to be your axis of symmetry. So let's just put that at 4. So this is x equals 4, right? So that is an axis of symmetry is written as an equation with an x equals. Okay, so I want you to picture this. So today what we're going to do first is draw the axis of symmetry first, then construct the parabola around it. So I know that the vertex is going to be somewhere on here. It might open up. It might be up here. It might open down, okay? So that's the information that I wanted you to have on this. So axis of symmetry and vertex. Are you ready to move to the paper now? Okay. So let's take a look at this that you have in front of you. And before we get into the actual notes part of it, I want to talk a little bit about these two. So right above y, actually we keep this out real quick because there's probably enough room here. So y equals x squared is called the parent function. And do you remember me when we first taught you linear functions, what the parent function was? The parent function, here are your two parent functions, right? In red, that's y equals x, right? That was the slope of 1, y-intercept of 0, 0. Nothing really fancy going on with that line. This blue version is the same basic version of this parent function of the line. So y equals x squared, nothing going on. It's about as dulled down as it can get. It's not moved yet. It's not changed shapes or sizes yet. So in the parent function, your axis of symmetry is 0, meaning go to the x-axis. So x equals 0. I'm going to actually put that in purple. Every time I write an axis of symmetry, I'm just going to use that color. It's purple to me, but it looks like blue probably for you. Up here it's purple. I swear. See? Yeah, there's no name on it. Okay? So then let's think about this. If your axis of symmetry is 0, and I'm going to put all my vertexes in red. Your vertex is an ordered pair, first of all, every single time. What is the first coordinate of my vertex every single time? If my parabola is going to be built around this axis of symmetry, my vertex has to be on the axis of symmetry, which means my x value is also 0. And in the parent function, it doesn't go anywhere either. So this is, I'm just showing you how to build this parent function. Okay? So, just for the heck of it, let's do a quick little table. Because here's the deal. If you're ever asked to graph something, an equation, like say y equals x squared, y equals x cubed, y equals 1x plus to the fourth, whatever, you don't have to know anything about it. If you can make a table of values, you can graph whatever function is put in front of you, right? Because all you have to do is choose some x values, plug it in for x, find the y values, and you got yourself some points, right? So let's choose our 5 basic points. Those are a pretty good coverage. I already told you that the vertex is 0, 0. So now what I'm doing is taking this x, plugging it in here, and squaring it to get the y. So what is negative 2 squared? Negative 2 times negative 2 is positive 4. Negative 1 times negative 1 is 1. 1 times 1 is 1. And 2 squared is also 4. So I have 5 points right now. I'm going to just show you where this parent function is made from. It's made from 0, 0, negative 1, positive 1, positive 1, positive 1, negative 2, positive 4, and positive 2, positive 4. And so that looks like if I were to connect it, and this is kind of the hardest part for kids to get. They're like, how do I, the only thing I need you to know is that it's not straight. These are not straight lines. So don't try to connect them straight because they don't go anyway. So just kind of try to curve it around. Put an arrow on the end of all of your parabolas because they don't ever end, just like a line does not. Okay? And that is the parent function. And in a parent function, here's your hint. This only works for certain ones. To know where your next 2 points are, it's just 1 up and 1 over, or 1 over and 1 up. That's if nothing happens with the width. See how the coefficient is 1? This is a little hint for when the coefficient is 1, you know that your next point is just going to be 1 up and 1 over. Okay? So if that's y equals x squared, what do you think number 2 looks like right next to it? Y equals negative x squared, meaning it's still going to go through 0, 0 because that's still just a 1 separate from the negative. And then it's just going to open down. So in this case, there is a maximum. In this case, there is a minimum. Okay, that's the kind of the prerequisite info I needed you to have. So are we ready to get into the meat and potatoes of this? Because it can get a little crazy. Are you ready? So, gear up. So, I realized that this process that I'm about to show you could get a little crazy, but I made a little cheat sheet for you up here. Your goal, first of all, they're given in standard form, right? You look at that and you might say, I'm going to factor that. Okay? And that might help, and you might be able to find your zeros. And in this case, you can, right? Because if I factor this, what are my zeros? X plus 6, X plus 2. So my zeros are negative 6, negative 2. So I know if you're comfortable with zeros and doing that, and if it's factorable, go ahead, do that. But not everyone is going to be factorable. So I need to give you an alternate way to do this. Okay? So remember yesterday how I said, okay, you got your zeros. Now where the heck is your vertex? That's what we have to do today. So are you ready for this? So the axis of symmetry is, I'm even going to underline it in purple or blue, it looks like you, because that's the formula I'm going to need to find it. So I'm going to take this information and I'm going to say that my axis of symmetry is going to be whatever the opposite of B over 2A is. And this is good old-fashioned plug away, right? This is 6th grade. If I give you variables, plug them in. So you know what this is going to be? Always keep bringing down your x equals. The opposite of, what is B? A is 1. B is 8. And I don't really care what C is, because I don't need C, right? I just need A and B. So B is 8. And you could do this calculation in your head. 2 times A. You don't have to show it. 2 times A if A is 1. It's 2. So this means 8 over 2 is 4. And I want the opposite of it, though. So whatever that works out to be, take the opposite of it. If that was a negative in here, I would take the opposite of it and it would be positive. So right now I'm looking at x equals negative 4. Hey, this is something that I didn't even anticipate. If you know the zeros, and I told you that a parabola is a symmetrical figure, how can you tell you already could have told me what the axis of symmetry was. Shouldn't the axis of symmetry be exactly halfway? Looked like I was doing a little yoga pose there. Halfway between the zeros? Doesn't that make sense that it's negative 4? Yes. JC.
I know it's like in the directions it says x equals negative b over 2a. Like, how'd you get like 2 right there? Like just the a.
2 right here?
Yeah.
Because the formula contains a 2 in it. And I took that 2 and multiplied it by the a, which is the coefficient there, and 2 times 1 is just 2. Okay? All right? So do you see that? Is that already making sense to you? That your zeros, okay? You don't need to find the zeros for this problem to do what I'm doing. So I don't want you thinking we're finding zeros today, because we're not. So are we okay so far? So now, this is where the new part comes in. I need to know where on this axis of symmetry is my vertex. I know look though, I know by common sense that it's negative 4 something, right? You know your vertex is on that axis of symmetry. So here's a really cool thing. As soon as you know what your axis of symmetry is, boom, bring it back down, and that's your x coordinate. So the only thing I have left to do is what? Find the y. And I shouldn't need to tell you how to do this. If you know the x but you don't know the y, what could you do? Substitute. Substitute what where? X in this whole equation. Yeah, so this is where it starts to get a little nutty, if you can keep track of it. So are you ready? My original equation says, okay, if x is negative 4, put it here, and do all that little calculations and figure out what y is, and you'll have your vertex. So, watch. I got to take that negative 4. I got to square it. And then I have to add it to whatever 8 times the negative 4 is, and then add 12 to that. So negative 4 squared is positive 16. Now be careful here. Watch what I'm going to do. Positive 8 times negative 4 is negative 32. And, I know at this point, most of these things you'll be able to do in your head. You'll be able to look at that and say 16 plus negative 32 is negative 16. Negative 16 plus positive 12 is negative 4. So when my x was negative 4, my y also happened to, it's a coincidence, it's not going to happen every time, my y also happened to be negative 4. So then I know my vertex. Okay? Now, here's the tricky part. I probably shouldn't have shown you. Well, no, it's okay, because if it was easily factored, I would say go for it. Find your zeros that way. I told you only need 3 points, right? You got them. You found them by either factoring and finding the zeros. However, what's going to happen if it isn't factorable? In other words, let's just do, let's just do that. Are you okay with that one? It factored. I found the zeros. I found the vertex. I did that. So let's go on and do number 4 right now. Okay? Because I don't think this one does factor. So I have to show you another way to do it when your zeros aren't staring you in the face, meaning it's not factorable. So let's take a look at this one. Ready? Let's identify our axis of symmetry first. Always start with that. The opposite of B over 2A. You don't need to rewrite that every time. I'm just rewriting it to kind of help you. So it's the opposite of, what is B this time? negative 12, over 2 times a. What is a? Negative 2. So what's 2 times negative 2? Negative 4. So negative 12 divided by negative 4 is positive 3. And the opposite of that is? Good so far? So I'm going to start with my axis of symmetry and build around it. This goes for when it's in standard form. Okay. Now, let's just say this doesn't factor. I don't know if it does. I didn't play around with it, but let's just say it doesn't factor. So we got to figure out, first of all, we got to try to figure out what our vertex is. Let's do that next. Okay, I know my vertex, if this is the midpoint, I know my vertex is negative 3 something, right? Do you remember what to do next? You plug that negative 3 in to the original equation. And this brings up a good point. So I want you to watch. We got a little order of operations question on our hand. I got 2 times negative 3 squared minus 12 times negative 3. You want a big piece of advice? Don't try to do that in your head. Okay? Write it all out. Then I need you to understand something from 6th grade. Order of operations says first do parentheses, then do exponents. So can I multiply the 2 and the 3 and then square that? No. You have to do the exponent first, right? So I'm going to take this 2 and multiply it by that 9. And what's a negative 12 times a negative 3? What's that? Oh, yes, thank you. I'm so glad you said that. Okay, that's going to change it. So what is a negative 12 times a negative 3? Positive 36. Negative 17. So this ends up being negative 18 plus 36 minus 17. Okay, and then this just calls for me to bring something to your attention. I know you know how to do that. You know how to add integers. You learned it in 5th grade or 6th grade, right? So I would really hate for this whole problem to go wrong because you accidentally were 1 or 2 off. So, and because you're in your 3rd trimester with 2 weeks left of 8th grade high school algebra, just pick up a calculator and do that to make sure you're right. Do you know what I'm trying to say? Normally, if this was me teaching you integer rules, no, do it in your head. Negative 18 plus 36 minus 17. It'll save you some time. There you go. You know you're right. Do you see the whole point of using this as a tool? Okay, you're not using it to do the problem for you, right? So after all that was said and done, I found out that when x is negative 3, y is negative 1. Okay, now, this is new. Do you remember me saying if that's a negative, that it's going to open up or down? Down. So right up here, right? It's going to open down. So I know it's going to go somewhere here, which means if it opens down, it doesn't have zeros. Yeah. Oh, sorry. Yep. Yeah, I just was hoping that was... Thank you. Shoot, I was hoping that was a good lesson to show you. But okay, so we have to go to positive 1. Which then everything that I was just saying doesn't really make sense. So, do you understand? Watch what I was going to say, though. If it was down here and you knew there weren't going to be zeros, then factoring to find the zeros is out of the question. So, at this point, you could try to factor to find the zeros. But let's just say it doesn't factor. Here's what you have to do. And this is where first hour was kind of like, what? So, you know it's going to open up. And you know it's going to go somewhere down here, right? It might go that far out. It might be a skinny one and go like this. So what you have to do is pick an x value that you want to plug in and redo this whole thing again. So you know what I want to do? I don't want to deal with plugging negatives in. So I'm going to either, well, you may have to, because if your choice is 1, I guess you could use 1. Okay? So if I choose an x value of 1, it'll tell me what my other one is. So this is the hardest part. You could choose negative 4, negative 5, negative 6, negative 7, negative 2, negative 1. You can pretty much choose any x value you want. I wouldn't choose like -10 or +8 because the graph is not going to be big enough for you to put that point. I'm looking for one more point. But somebody then first hour said, I thought you said you needed 3 points to graph a parabola. Why are you only looking for one? Yes, because if I find one, I could use the axis of symmetry to find its mirror image on the other, right? So I'm not really looking for two. I'm looking for one, and then going to put the mirror image of it. So you know what? Let's just use -1. Okay, that's safe, right? So let's do this. Again, we got to do this whole process. So I'm going to say y is equal to, when I'm making x, -1, -2 times -1 squared minus 12 times -1 minus 17. Okay? -1 squared is +1. +1 times -2 is -2. -12 times -1 is +12. And then minus 17. Now this one, you probably don't need a calculator for this one, right? So this is going to give you +10. And +10 minus 17 is what? -7. So let's stop for a minute. There's a lot going on right now. What is it that we were just doing? We were trying to find one more point, and you know what might not be a bad idea to put right here is, because then people might go back and say, oh shoot, what did I make x? I mean, you could just look. So maybe start before you even plug it in. And now that you have this, just real quick go back up there and plug it in. All right, are you seeing this come together? So now I go to -1 and all the way down to -7. And if that's -1, -7, then the other point is going to be on the other side. If it's 2 spots away from the axis of symmetry to the right, then it's 2 spots away to the left. And we got a little skinny one. Okay. That one obviously is a little more narrow than the one next to it, right? I mean, I know they're not perfect. Okay. So it looks like my intercepts could have possibly been -4 and -2 if I would have done it correctly. So we could see if that factored, if that's what it would have been. Okay? Are you okay so far with this? I'm going to do one more, and then you're on your own for the rest. So let's do this top one right here. Because the first couple times it's like taking me forever to talk through it. So it seems like it's not going to take you 15 minutes to do one problem. So let's start out by finding that axis of symmetry. Ready? So, the opposite of B over 2A. What is B? -12. What is 2 times A if A is 3? 6. I'm glad this happened. Because now I want the opposite of a -2, which is +2. Do you see how that all worked out? Draw your axis of symmetry. Okay. Now remember, this is all while it's in standard form. This is why this works. Now that I have my axis of symmetry, I know that my vertex is right on that axis of symmetry. So it's going to be 2 comma something, right? To figure that out, I would plug 2 in up here, right, to figure out what that next spot's going to be. Okay, so that's going to give me y equals 3 times 2 squared minus 12 times 2 plus 11. And maybe to get you to kind of see, for those of you who like that color aspect of it, you just put that 2 in for x. You got a little bit of calculation. Be careful on it. Don't do 3 times 2, because that would be breaking operations. 4 times 3. -12 times 2 is -12, or -24. Plus 11. Okay, so this is -12 plus 1. Okay, got my vertex. And now all you need, So let's, so,
Negative 12 plus 1.
oh, okay, yeah.
Yeah. That's good.
Did you get -1, anybody?
Yeah, I did.
Yeah, you may have done, what do you mean, how did you do it differently?
No, I did.
Oh, you just did the 12 and the 11 first and got 20. I don't know, did you get -1?
No, I just, the first time I wrote it.
Oh, I put a 1 instead. Okay, so now everything's good, right? Okay, so I got my vertex. So it's axis of symmetry. Find the vertex, which is +2, of course. Excuse me, -1. Then I could choose to factor, but here's the deal about factoring. It may not be factorable. So doing the X box doesn't take like 1 minute, right? It takes a good amount of time. Do you want to do all that just to find out, oh shoot, it doesn't really factor? No. So wouldn't you just rather pick another point, plug it in, and be sure? So here's the next deal. Pick another value of X that you can see. Why not pick 4? Right? So let's pick another value of 4. Y equals 3 times 4 squared minus 12 times 4 plus 11, and you do it all again. So you have to do 16 squared, or 16 times 3 minus 48. So probably what I should have done up here is put that I was choosing 4, right? So when X was 4, Y was 11. And we are almost done. Holy cow, this is a lot of steps. So now that I found out that Y was 11 when X was 4, I have 4 comma 11. And if I have that point, then, yeah, this is a really thin one. Then I have 2 to the right and 2 to the left. So this one is real narrow. Okay. You think you got it? Seems like a lot, but basically if you go, and that's kind of why I gave you those little hints at the beginning. First, find the axis of symmetry. Then use that to help you find the vertex. Then find the point. So if you need a real quick, it's X equals. Step 2 would be V equals. Step 3 would be 1 additional point. Axis of symmetry, vertex, and you do the same process for these two, correct? Okay, whew, that was tough.